All right, let's talk about error handling. You know, it's funny, it's one of the first things we ever learn in programming, but it's probably one of the last things we ever really master. I mean, anyone can write code that works on a good day, but writing code that handles failure with grace, without becoming a complete disaster of nested if statements, well, that's the real trick, isn't it? So let's jump right into this chapter from cleancode and see how we can all get a little better at it.
I love this analogy. Think of it like planning a road trip. You map out the perfect route, but you still pack a spare tire, right? But you don't drive with that spare tire sitting in your lap blocking your view of the road. No way. You keep it in the trunk, out of the way, until you actually need it. That's exactly how we should think about code. Things will go wrong. It's a guarantee. Our job is to handle it cleanly, without letting the error code obscure the main point of the journey.
And this quote from Robert C. Martin really hits the nail on the head. This is the whole problem we're trying to solve. If your error handling makes it hard to see what your code is actually trying to do, you're doing it wrong. We've all been there, right? Staring at some function that's 90% error checks and 10% actual logic, just trying to figure out what its main job is supposed to be.
Okay, so how do we climb out of this mess? Well, the first and most fundamental change we can make is to stop using old-school error codes and fully embrace exceptions. And trust me, this is way more than just a style preference. It's a completely different and much cleaner way of building our software.
Just look at the difference here. With return codes, the burden is all on the person calling your function. They have to immediately stop and check for an error, which mixes your what-if logic right into your happy path logic. It's messy, and even worse, it's so easy for someone down the line to just forget to check. But with exceptions, the two concerns are totally separate. Your main logic flows clean, and the error handling is dealt with in its own dedicated space.
Let's look at a real-world example of this chaos. I mean, can you honestly tell me what this code is supposed to do in under 5 seconds? You're forced to navigate this maze of nested if-else blocks just to find the one line that does the actual work. The main job is completely buried. This is exactly what we need to get away from. And now, check out the after version. Ah, night and day, right? It's so much cleaner. The code inside the try block tells you a simple story. I'm going to try to shut down. That's it. All the messy, what if it fails, logic is tucked away neatly in the catch block. The concerns are separated, and the code immediately becomes easier to read, understand, and maintain.
So we're all on board with exceptions. Great. But just using try-catch isn't the whole story, because you can still make a mess if you're not careful. We need to be intentional about crafting exceptions that are actually helpful, and that brings us to building a proper toolkit for doing just that.
The book lays out 4 really solid practices. First, and this is a cool one, write your try-catch finally statement before you write the code that goes inside it. It forces you to think about failure up front. It's like setting up the safety net before you walk the tightrope. Second, try to stick with unchecked exceptions. Third, always give your exceptions context. Tell us what went wrong. And finally, think about the person using your code when you design your exception classes.
Now, that second point about using unchecked exceptions can definitely stir up some debate, but the reasoning is super solid. With checked exceptions, if you change one little thing in a low-level function, you could be forced to go and change the signature of every single function all the way up the call stack. That's a classic violation of the open-closed principle, which says our code should be open for extension but closed for modification.
Let's dig into that last point, defining exceptions for the caller. Imagine you're working with a third-party library, and it can throw 3 different weirdly named exceptions. You end up with this repetitive, ugly catch block where you're basically doing the same thing over and over. It's just noise.
The clean way to handle this is to use a wrapper. You create your own simple class that talks to that messy library. It catches all those weird exceptions and translates them into a single, meaningful exception that makes sense in your application, like port device failure. Now your code is simple. You catch one thing. And as a bonus, if that library ever changes its exceptions, you only have to make an update in one place, your wrapper. Okay, this next technique is a little more advanced, but man, it is so elegant when you pull it off. Sometimes, the best way to handle an error is to design your code so that the error can't happen in the first place. So you have to ask yourself this question. Is this situation a true, unexpected catastrophe, or is it just a predictable, alternative outcome that happens sometimes? If it's just a normal thing that can happen, using an exception is like using a sledgehammer to crack a nut. It's total overkill. And the solution is something called the special case pattern. It's brilliant. Instead of throwing an exception or returning a null when something predictable happens, you return a special object that knows exactly how to handle that scenario. The best part? The code that called your method doesn't even have to know anything special happened. It just works. Here's the perfect example. The business rule is, if an employee has meal expenses, use that amount. If not, use the standard daily amount. See how the before code uses an exception, meal expenses not found, to handle the totally normal case of an employee not having any expenses? It works, but it clutters a simple calculation with all this try-catch ceremony.
Now, look at the after. Poof, the try-catch is gone. The logic is one beautiful, simple line. So what's the magic? Well, now the getMeals method returns a special per diem meal expenses object when it doesn't find anything. And when you ask that object for its total, it just gives back the standard daily amount. The calling code is completely oblivious, and that's exactly how it should be.
All right, let's bring it all home with two final, absolutely non-negotiable rules from the book. And they both revolve around what is arguably the biggest source of bugs in software today: null.
Rule number 1 is simple and direct. Stop returning null from your methods. Just don't do it, ever.
So why the hardline stance? Well, because every single time your method might return null, you are forcing everyone who uses it to add a null check. You're creating work and setting a trap, because if someone forgets that check just one time, bang, you've got a null pointer exception crashing your application. It's a ticking time bomb. Instead, return an empty collection, or even better, use that special case pattern we just talked about.
And the companion rule is just as critical. Don't pass null into your methods either. Returning null is bad, but passing it in can be even worse, because what is a method supposed to do with an unexpected null? There's really no good answer. If you can just establish a simple convention on your team that we don't pass null, you eliminate an entire category of bugs from your code right off the bat.
Ultimately, all of this comes back to one central idea. Readability and robustness are not opposing forces. They're two sides of the same coin. When we treat error handling as a separate, important concern, we write code that is both incredibly clear to read and incredibly difficult to break. So here's the challenge. The next time you're looking at your own code, ask yourself that question. Think about that road trip. Is your spare tire, your error handling, tucked away neatly in the trunk, ready for an actual emergency? Or is it sitting in your lap, making it impossible to see the road ahead?